a relaunch of certain activities of ISRO, giving more emphasis to research and giving a helping hand to research organizations outside ISRO and different engineering colleges. So we are very happy to welcome Dr. Venkitakrishnan, and I also welcome all the participants of the program, and I hope the research scholars of the college, they are a very good number, are also present here, and they can make use of this opportunity to link with Dr. Venkitakrishnan and get very good support for our college. You are welcome, Venkitakrishnan.
Thank you so much, Professor Krishnakumar, and all my colleagues and my alma mater. It's a great opportunity for me also to get linked with you in the critical opportunity, actually.
Venkitakrishnan, you can just speak about the two phases of your lecture.
Yeah. See,
and the question session in between.
Yeah. Would like to see that my small talk, whatever I'm going to give you here, is divided into two phases. Phase one is the existing phase, exactly where we are reached right now in space arena in India. And the second phase is what we are going to do in future right now. There is a small transformation happening in ISRO structure, the way in which we look at things and way in which we are going to work right now from here onwards. Everything is going to change. And thanks to COVID also, because of a crunch of funds also, all put together. So I would like to see that my talk is phase one, exactly where we stand right now, around half the content of that, maybe half the time of that, for 40-45 minutes of 20-22 minutes. I will talk about the existing scenario, where we are reached right from where we started, and how we have traveled along, and the future, how it should look like, how we are going to chart it out in the future activities, taking the entire nation along with us. That is the important thing what I want to stress upon here. Okay. So I have some presentation here which I'll go through. I think all of you can just enjoy that. One minute. Yeah. I hope it is visible. It is visible to all?
No. You have to share the presentation.
1 minute. Just a minute.
I think it's not still visible.
No, 1 minute.
Those
Just
three buttons on the right bottom.
Right bottom. Okay.
More options.
Share is not on. That's why share is not. Do you have to give me the share right? Just see.
I think
it is not given to me.
Yeah, I
Maybe
think I'll check with that. I'll check with that.
Sir, on the right corner.
Dr. Ajay.
Yes, sir. So right corner, bottom, you have a present now button. You have to present now. You have to click that present now button.
Okay.
And you have to click the window.
Share screen is given.
Present now, and you have to click that window. A window. And you have to select that window.
Hello?
Yes, sir.
Hello, can I go ahead? Krishnakumar?
No.
It's not visible now. Professor Ajay?
It is not visible.
Yes, sir. You have to present. You have to click that present now. And no, sir. You have to click that present now button. Present now, and you have to
Bottom.
click that bottom, and you have to click that window. A window.
Now, please stop 1 minute. 1 minute. 1 minute. I'm doing the same thing what I'm doing. Just a minute. Okay. One minute.
Yes.
Yes, sir.
Just a minute. No, 1 minute. The other window is not coming, no?
Sir, when the window comes, you have to click on the window and then.
No, window is not coming. That is the problem. Window is not coming. 1 minute. Chrome wants to share contents of your screen to choose to share. The other window is not coming, no? Is it okay now? Let's see. Krishna Kumar,
Yes.
I am not getting the second window at all here. I don't know what is the reason.
So without a presentation, can you proceed?
Can you
No,
make
it's
it?
a 25
I will
GB
open.
big one. That's
That's why
why.
I did not do that because of that only. Because what
25 MB.
the second window is not coming at all. No, to make it open. 1 minute.
Are you using PowerPoint, sir?
Are you using PowerPoint?
Okay. You just click. You make a slide. Put it in slideshow. Then you come back to this Google Meet and give the present now button. You have to click that present now button, and from that you can take the A window. A window is there's an option. When you click that A window, another window will open, and you have to click on the particular document.
Okay, but that second window was not coming so far. Okay, 1 minute.
Now you first open the presentation.
1 minute. 1 minute. Yeah. Is it visible now?
No. Yes, now it is. Yes, now it is. Okay, fine.
Okay, fine. Okay. Fine. Okay. My time starts now. Okay, sorry. So, right now, exactly where we started long back, maybe 60 years back or so, from there, where we stand right now, I'll be covering in phase 1. Just let's go now. Okay. Evolution of National Space Program. You can just see humble beginnings, 60s to 80s actually, from sounding rockets, what we started like pencil rocket, rocket sounding rockets, RSR series, RH series, 200, 150, 600, 750, like that, up to 800 diameter we have gone. And those days, Vikram Sarabhai was working from a church in Tumba Equatorial Rocket Launching Station in Trivandrum. Tumba being very near to magnetorial equator, it was selected as if at a convenient spot for cosmic ray studies for him and atmospheric studies, and measured expansion from 1980s and 2000. 1983 I joined actually. You all may be knowing that exactly 1983 I joined. That time SLV was already launched, and augmented satellite launch vehicle ASLV was on the slate, and it was an augmented capacity from 40 kg of from SLV3 to 150 kg of 2 strap-ons were added, and closed loop guidance also was added. Actually, open loop. It was open loop guidance for SLV3 and was closed loop guidance for ASLV. These were the two small changes we made. Step by step, ISRO has gone up actually, and up to 2000 we have gone to stabilization of commercialization of stabilization, commercialization, and development of entire PSLV, and has gone fully commercial, and GSLV Mark II with cryogenic stage and Mark III with updated cryogenic stage, and sustained growth after 2020. You can see that we have gone on board commercial launches all over the world. And this is phase 1.0. I'll be covering that in 20-25 minutes. We can do a small half break after that for question and answer session. Then rapid acceleration beyond 2020, what I'll be talking today. That is a crux of the entire thing, presentation, what I'm going to show here. Sarabhai's vision, 60s to 80s, second to none in application of advanced technology for benefit of society. Initial clusters, actually Ahmedabad for payload electronics and physics, Trivandrum for 17 rockets and solid propellants, and Sriharikota is rocket launching site. It's a beautiful site actually. It's one of the best port in India, spaceport in the entire world. To compare it from a point of view of launch capability, and it was selected just on the eastern coast because it should match with the rotation of the Earth. Actually, it should be on the direction of the rotation of the Earth. Western coast we cannot have it, so it should be on the eastern coast, aiding the rotation of the Earth. And the spent stages should fall in the vacant sea where no landmass or inhabited area is there. That's why this 143 is the azimuth actually. If you see from north is actually 0, and full east is 90. And if you come down, I hope you are able to follow me. 140 or 103 or 104 is azimuth angle. If you go by the azimuth angle, no landmass is there. We can go between Philippines and Indonesia and go beyond up to Australia, and behind Australia between New Zealand. To that extent, we can go without anybody coming in the way, any landmass coming in the way. Unique management style, bring together talented individuals all around the world and let evolve the ideas to result. That was Sarabhai style. Leverage domain-specific international expertise, yet rooted to India. That is a specific example. And after the sudden demise of Sarabhai, Dhawan took over, shaped this and structured the program. He structured it a little more properly. Institutional mechanism like Department of Space and Space Commission was started. Indigenous launch vehicles like SLV and ASLV, building blocks for higher capacity launch vehicle mechanisms for result-oriented space program, like national, natural and remote, natural resource mechanisms, and ADCOS, Committee for Science and Specific Applications. Industrial interface and partnership started by that time. Earlier in the period, HAL Kanpur, HAL Nasik were involved in motor case building and structures building for ASLV and all. Later, it was shifted to Bangalore, and HAL Bangalore started indulging from PSLV onwards. And building on solid foundation in 1980s to 2000s, if you see, during my period, after my joining, I believe, liquid and cryogenic engine propulsion started development. We had a tie-up with SCP France for the air liquid France, we call it right now, for the Viking engine, and it was renamed as Vikas, Vikram Sarabhai, Vikas engine, after adapting to Indian conditions and slightly remodifying and re-engineering. And that is one of the workhorse for the PS2, second stage of PSV right now, and PS4, four-stage engine we developed ourselves, and it's a twin engine actually. With a bipropellant actually. We have developed it in India. And so it's another workhorse actually for PS4 stage. PS3 being composite motor case solid, and first stage being solid again. And it was 139, S139, 139 ton with 3.2 meters, 2.8 meters diameter actually. Then from there, from Mark III, we have gone to 4 meters. It's a quantum jump. From ASLV, it was 1 meter diameter, 2.8 PSLV, and 4 meter. Now we are going to a heavy launch vehicle called HLV, called 6 meters actually in diameter. That will put around 6,000 ton in geo. That is one thing on the anvil right now. New centers across the station was started. Perfecting the workhorse PSLV. IRS program started. Remote sensing satellites in sun-synchronous orbit started. Then INSAT program for communication also was started during this period. Growing in stature from 2000 to 2020, that is a period right now exactly, and this is a quantum jump what we are going to have right now from here to. We need to see that more resources are pumped in. We don't have much resources in India from governmental resources, so we need to see that more of private players are also roped in, and it is being a strategic sector. It was not so opened up so far to any public, private and public enterprises, private enterprise so far. Now we are opening out to private and startups also. A lot of startups and a lot of private industries are so much shown interest. Right now itself, within 20-25 days of reform announcement itself, they have come forward to see that they wanted to see that they want to make rockets, and they want to make small satellites and micro and macro satellites and medium satellites. So all these interests are being now just studied, and how to react. We are going to make a mechanism. I'll be checking it number phase 2. And mastering the cryogenic engines also happened during this period. Operationalizing the 3 indigenously developed launch vehicles, interplanetary missions like Chandrayana and Mangalyaan also happened during this period, demonstrating our might and capacity. And science mission called AstroSat, that is one of the important, unique satellite what we have launched in the entire of spacefaring nations. Commercializing the launches, navigation constellation, Navig series. So we have got three actual applications of the main applications of the satellites. You must be knowing that. Earth observation, remote sensing. That is one thing for planning and urban planning and any kind of resource planning on the Earth and Earth's surface and underneath the sea also. We have got infrared camera, radar imaging satellites which can go beyond the surface of the sea and see visible infrared, also invisible infrared also we can see beyond and underneath the sea also. So RISAT, there is one thing. RISAT is one more thing which we can see is so strategic applications for our defense applications also. We can use it because we can see it has got night vision also. So interplanetary missions, and after that now we are gone for AstroSat and navigation and communication are another 2 applications of main application of satellites. And GSAT series also now we are commercializing. And we can see the glimpses of journey so far what we have made right now. Whatever I told right now has been put pictorially in the coming slides. You can see how ISRO is spread across the entire of country. You can see Prime Minister, we are reporting to Prime Minister, Department of Space is coming. There is a lateral powerful body called Space Commission, which was started by none other than Satish Dhawan. And Satish Dhawan's and Vikram Sarabhai's 100th birthday anniversary is happening this year. It is incidentally the 100th birthday anniversary year. Same both about same year actually in 2020. We are just celebrations are over. Department of Space is another. That is a Secretary Department of Space, ISRO chairman, and Space Commission chairman. All are chairman ISRO only. That is a unique, important feature of atomic energy, defense as well as space. The bureaucracy is not there. There is no IAS or anybody coming in picture as Secretary Department of Space. Our own chairman is Department and Secretary Department of Space also. There's a unique feature wherein we are able to take decisions much faster than compared to other departments. And ISRO, we have got headquarters in Bangalore, not in Delhi, and atomic energy is headquarters in Mumbai. And defense, of course, now they're shifted from Hyderabad to Delhi. And there is Antrix Corporation long back. Right now we are changed into NSIL. Actually, you must be knowing that New Space India Limited, another commercial arm, has been brought into picture right now. To see that, I'll be talking about that in the second phase of my talk. And the first lab what Vikram Sarabhai started was Physical Research Laboratory. You can see PR on top, and National Atmospheric Research Laboratory (NARL) in Hyderabad, Tirupati, and NESAC Northeastern Satellite Application Center in Shillong. Then SCL Chandigarh. Right now we are taken over Chandigarh from CSIR, the lab of a semiconductor lab in Chandigarh. ISRO has taken over almost a decade back, and in electronics also we are leapfrogging. And in Trivandrum we have got an institute wherein we are able to get our own for the intake for the HR human resources, Indian Institute of Space and Technology. They are giving the undergraduate and postgraduate program for our own resource management, human resource management. Apart from that, we got ISRO Council, which all the ISRO centers and council members, including me, and the major centers, of course, VSS in Trivandrum. You must be knowing that it's a lead center for rocketry, and Liquid Propulsion System Center in Valiamala and Trivandrum itself, and Satish Dhawan Space Center, SHAR in Sriharikota range is called SHAR, and ISAC, earlier ISAC, which now we renamed as UR Rao Satellite Center after his demise. That is in Bangalore, which is giving the actual propellant as well as the satellites. So satellites, we call 1K, 2K, 3K bus satellites. If it is 1K, it is 1,000, 1 ton class. 2K means 2. We got standard buses right now, and propellant systems, everything is standardized. So whatever we want, we can immediately assemble it, and modular and segment modularity is there. And Satellite Application Center in Ahmedabad, catering to all kind of payloads, cameras, and what is the transponders, what is being used as a payload inside for use for utility purpose, that is being charted out and designed by Satellite Application Center. They are the payload masters, and national. And after the entire thing for the remote sensing, the data is coming, the data is processed on the entire of the country across regional remote sensing centers in almost all state capitals. We have got in Trivandrum also one. And the National Remote Sensing Center in Hyderabad is coordinating the entire activity to see that whatever data coming from the top is being analyzed properly and interpreted and disseminated to the required agencies. And we've got a new vertical right now. You must be knowing that Gaganyaan is on the slate, wherein we are trying to put a human Indian in space, and human space flight center that also is in Trivandrum. Eventually that will be shifted to Chitradurga in Karnataka, in the middle part of Karnataka towards almost north, wherein a cluster of lot of other institutions like DRDL, Atomic Energy also have taken land, and it's a big land which is getting developed there. And apart from that, we got small units like ISRO Inertial Systems Unit in Trivandrum, where their inertial system and navigation systems are being specialized. ISRO Propulsion Research Complex in Mahendragiri, wherein I was a director for some time back before coming us and taking over as director, capacity building program office here, and master control facility in Hassan as well as Bhopal right now. You must be knowing that these facilities are the almost center of India, because any attack coming to these centers will jeopardize the entire of the asset or spacecraft what we are having. So to see that it is not in the shores or somewhere, we can visibly see that any attack attempt on these kind of centers can be easily seen and thwarted. We are having MC of Hassan as well as MC of Bhopal in almost the central land mass of India, and ISTRAC is having wherever possible we are duplicating the data centers. ISTRAC is having in Bangalore as well as now in Lucknow 2 centers. So we are having copy of all the files and all the records in both the centers, so that if one get any problem, we can easily activate the other through the other things. And we have got laser and electro-optical systems payloads, LEOs in Bangalore, and Indian Institute of Remote Sensing, that is where remote sensing interpretation, data interpretation training is being given in Dehradun. And we are having a DECU, Department of Education and Continuation Unit, that is we make all kind of documentaries for telemedicine and other things. I think I do it a little more here because this is spread of we are of course around 18,000 more people spread across the entire India, as you can see from the India map what is depicted here. And Earth observation satellite, you can see the evolution. I just put in one slide, captured the entire thing in one slide, whatever we have happened so far. Right now from 1 kilometer resolution Bhaskara, which has gone from Russian satellite Sputnik to right now Saral and other 2018 microsat and HISIS. We have gone for high throughput satellites. And 3-dimensional imaging, you can see TDI imaging, we can also see stereo imaging. Step and Stare is one technical experimental satellite, TES. We have got experimental satellites also in between, not for any other purpose, to prove some technology. Also we have flown some satellites in between. That is the way in which we normally grow, because we don't want to unnecessarily pump in a lot of money in the satellite. So whatever payload want to improve, sometimes one launch will exclusively cater for that alone, to see that technology is proven, so that next launch is more advantageous and more important and more useful. And we got Saral. Saral is called actually satellite for Altica and Argos with the French collaboration, and with Altimeter and Mechatropics. You must be knowing that that is for meteorology and other things. So oceanography, ocean surface, atmosphere studies, and Cartosat. Cartosat is for nothing but for the entire of mapping of India and urban development. Cartosat 2 series, whatever we are now put in 2016, 2018 is for strategic applications for boundary monitoring of our defense services, and defense also we are giving a lot of training. Defense personnel also we are giving training as ISRO Bangalore as well as in Lucknow. And you can see the EU application in one slide exactly how the Earth observations applications. Here in all these things, a lot of avenues for job opportunities are there right now. Also, you must be knowing that. We have got one software called MOSDAC. MOSDAC actually it's completing almost a decade right now after the development of MOSDAC. What we have developed long back, meteorological and oceanographic satellite data services called MOSDAC. It's being right now used across the country by a lot of startups and for even you can see what I can say for insurance applications of crop and all these things. So for insurance prediction, if you want to get a loan from the bank depends upon the MOSDAC software to get the prediction how much crop will be there, from the forecast of the weather as well as the whatever entire thing, and how much will be the coming, what will be the yield and all these kind of forecasts. Scientifically it is being extrapolated and given, which is being banked by the lending authority to see that what kind of loan we can give to the farmers. So all these things are actual use of put to use by the data what is being given by the Earth observation satellite. Agriculture crop inventory, watershed development planning and monitoring, irrigated command area monitoring, irrigation infrastructure monitoring, potential groundwater zones, potential fishing zones, Chagara, as we call now. You must be knowing that Chagara, what we call actually potential fishing zones, urban infrastructure planning and biodiversity in landscape. The entire biodiversity being of Western Ghats also being captured, and that study was entire study what we have done. Our Gadgil as well as our Kasturirangan report were made by using these images. And we have got disaster management. As you are all aware that the kind of disaster right now we are getting, we don't get much of casualties right now. Long back, I remember that when we were traveling from Delhi back, I was halted at Visakhapatnam or I think Vizag for almost a day, 24 hours, because the entire of the platform and the railway station was blown off, and a lot of casualties were more than 10,000, I believe, that particular day. Now, if you can see that it is only 1 or 2, that too, those who are venturing out without caring for warnings also getting into any kind of problem. Otherwise, we can see the casualty will be almost zero. So that is one advantage we are having right now. Natural calamities, the casualties and the kind of damage what we're getting is very minimal, and damage assessment after the entire thing is over for the insurance also. We are getting a lot of demand, early warning and hazard management. You can see developmental governance, e-governance, all are being facilitated by GPS. You must be knowing that GPS is getting into almost all kind of vehicles, and that is going to be a kind of data you can use for anything, including our gold smuggling. Now you must be seeing that what kind of thing is going on. GPS has put off and put on, all these kind of things, or you must be listening in the conversation what is going on right now. The existing scenario, developmental governance, community participation, local wisdom and action plan, all are included in these EU applications. And coming to satellite communication area, you must be seeing that from INSAT-1 from foreign Apple area and payload passenger experiment. They called Apple actually. That was one of the things. See, you must be knowing that in Sarabhai's period, everything was first experimental, then only we have gone into practical. Ariane payload passenger experiment is called Apple. That was one satellite purchased, and actually we have put in Apple itself to see that how much it is useful for India. Apart from that, you are all familiar with the word SITE. That is satellite instructional what do you call instructional television program, satellite instructional television program. That is the first telecast what we have done for rural areas to broadcast and see how much television is important for communication in India. Apart from that, satellite technology experiment program also. After that, telecommunication also, we are in STEP, one program called STEP. These were the stepping stones for actual of the three. And after that, we developed IRS, INSAT, and now coming to GSAT. So you can see that INSAT-1 series were launched from Ariane rockets from French Guyana. After that, slowly we have migrated to GSAT. GSAT series are almost launched from India itself, apart from the heavier satellites right now. Up to 3.5, we are launching from India right now, and above and more and above 3.5, we are going to now also to abroad. The coming future, immediately we will be enhancing the GSLV Mark III capability to 4 ton and 4.5 ton. After that, HLV will be coming for 6 tons. After that, we'll be Atmanirbhar. Actually, we won't be going out for any more launches for outside countries. And you can see the high throughput capacity satellite, what we are right now in Ka and Ku band frequencies. We have just now launched 2018. And direct to home broadcasting, teleports, cable broadcast, VSATs, and telecoms, and DRT applications, actually data relay transponders, that also you can see that. And telemedicine, around 386 hospitals were actually linked now. Now it is more. During COVID period, we have got a lot of applications, and a lot of linking was done. Actually, I don't know the exact number right now. We'll be getting it right soon. Tele-education, now you must be knowing the entire of the country is going through Victor and EduSat right now also. More than 56,000 classrooms are right now. COVID, post-COVID and COVID scenario, you must be knowing that the entire thing is now online, depending upon our EduSat and one more satellite what we have launched after that. Village resource centers were established for all other applications of village and remote areas. Disaster management support were given National Asset Director. Okay. This is the communication. Apart from that, meteorological navigation satellites also evolution. You can see very high resolution radiometer VHRR, and 1990 we have started. In 2016, imager and sounder rockets. Up to that, INSAT 3DR. Apart from that, IRNS is one way. We have got there is one important element called atomic clock in this navigation satellite. The clock synchronization should be exactly equal to international standards. We have indigenously made it and put it in the IRNS right now. It's going on very well. After that, we have developed a Bhuvan software called almost similar to Google called Bhuvan. We have our own GPS program or software what we have developed, and the Navik National Navigation Indian Continent through Indian Continent. Navik also is another land receiver we are having to see that how we are receiving the data from IRNS up to 1G and 1F. Navigation through Indian constellations. Navik, you can see fleet and logistic management, aviation. Aviation also we are trying to connect now between through ATCs. Between the ATCs, there is a gray zone available right now. We are trying to connect that also across the Indian Ocean as well as transatlantic through aviation with collaboration with other countries. And we are also supporting. So entire aviation will come through navigation control through constellation and GPS right now. Otherwise, with ATC connected, maritime service and operations, power grid synchronization. Of course, definitely this we are doing it for NTPC also. Timer and clock power grid synchronization. You must be knowing that. And GIS services, geo information services, precise timings, geofencing. Geofencing, we have been going into geofencing of COVID patients right now. You must be this being effectively used in almost all kind of tracking of people and seeing that they are quarantined properly. Geofencing is one of the important tools that is being used right now. Mapping and geodetic data capture, aid to hikers and travelers, and mountaineering and all these things. An important thing what we are doing for GPS, Earth and atmospheric studies, infrastructure planning, disaster management, forest and mining, and search and rescue. See, all these areas, a lot of startups are coming up with application generation of mobile app generation, so many other things actually. A lot of startups are coming with each and every area. That is one important scenario what is happening right now. We are concentrating on the use of satellites much more than actually satellite launching itself, because we have been giving it to state services so far, but not much of people have come forward to use it and to make it used for the common man of India, to grassroots level real use of this. So we are getting into that area also by promoting startups and all. So the coming 1 decade will see the very intense use of space and space technology applications across India. This is space transportation as it has evolved from 40 kg from low Earth orbit to 150 kg low Earth orbit for SLV and ASLV, and PSLV of course is a workhorse right now. It has gone from 1000 kg to 1840 kg in sun synchronous orbit right now, and we are going into. You must be knowing that GEO also we are going through PSLV, and interplanetary missions also we have succeeded in through PSLV itself. And GSLV, of course, was supposed to be used in Chandrayaan 2. Actually, when the payload mass has gone up, we have shifted to Chandrayaan 3. And you are all aware that Chandrayaan 2 was just a whisker. We have failed in the last minute of 8 seconds or so, or 2.1 kilometers just before soft landing. We lost the communication, and there was a crash landing. So we are now going to Chandrayaan 3, which will be now next year. We don't be having a rover and a lander separately. We'll be having a clubbed rover and lander put together. A new technology what we are going to adopt to see that the risks are minimal. Actually, risk mitigation actually is being done. We are having an orbiter and lander and rover club together actually in Chandrayaan 3. And semi-cryogenic engines is 20,000 Newton. Actually, one more very powerful engine what we are developing. And here the cryogenic instead of liquid oxygen we are going to use ISRO, we call kerosene, almost aviation type of refined kerosene we are using. It's a low-cost fuel. Handling liquid oxygen, liquid hydrogen is very, very difficult actually. So we are having liquid hydrogen, of course. Liquid hydrogen is being replaced by ISRO, what we call kerosene. And Andhra Sugars is making this special type of kerosene, which is called ISRO. We have started making it. And this engine is fast progressing. The testing is being done in Ukraine right now, and we are going to have test facility in Mahendragiri also in the coming years. To fast track the entire thing, we are taken to Russia and Ukraine, and we are going to test it there. First engine is being tested there. And you must be knowing that we are into Gaganyaan, and Gaganyaan activities and human in space mission activities have started almost a decade back in ISRO. SRE experiment was the first of its kind to prove that in space recovery capsule experiment, what we call it. There was a capsule which was in the space for 7 days, and we recovered and recaptured it and re-entered it. And we got silica tiles, thermal barrier system to see that the re-entry heating is being managed properly. And we have been able to succeed in bringing that space recovery experiment long back in the splash touchdown in Bay of Bengal, and we are able to capture it and we bring it back. Now it's also available. You can see it in, if you go to Space Museum in Tumba, you can see that when they are thinking there is no charring, nothing has happened to the surface. Okay, so thermal barrier coating and silica tiles are proven. Slowly we are into the system actually. After that, we had a care mission. Of course, next I'll be talking about that. After that, crew module is there, and there is service module which are coming. Crew module, you know that if any kind of eventuality in the launch itself, before the launching itself in launch pad itself, the crew has to escape. The crew escape system we call CES, pad abort test. In the pad itself, the entire thing will be aborted. That's what we are showing in the right corner here. Pad abort test module is there, and the entire thing you can ejaculate and come back, and the crew will be safe before any kind of calamity in the launch pad itself, aborting the pad and escaping the crew. So this system also was proven sometime back. Pad abort test also was proven. So we are going in step by step. You can see that after that we are in the experimental mission of Mark III. Before going into the actual C-25 cryogenic stage, we have the dummy stage. We have proven what we call care mission. That's a crew module experiment, actually re-entry mission, re-entry experiment. We call it CARE, and that also was proven as a part of a HSP program. Now we are all slated to take off for HSP human space mission called Gaganyaan, and in between we have got two technology demonstrators, what we call it air breathing propulsion. You must be knowing that you require oxidizer also for any kind of propulsion what to happen in, because there is no oxygen available in space. You have to carry an oxidizer also. As a payload, and you got the more of propellant you carry, the less of payload you can carry. So we need to see that in the ascent phase of the rocket, we are able to take atmosphere oxygen and liquefy it in the high velocity and use that. That's called air breathing. So we are not carrying any kind of oxygen there. We are converting the atmospheric oxygen to liquid oxygen, and that is being used as an oxidizer. And fuel alone will be carried. That much of inert mass we can save, and that much of payload we can pump in. That is the advantage of air breathing engine. That also we have proven right now. Sometime back as a technology demonstrator, a quantum jump will be there once you are able to demonstrate that in a massive, larger scale, and able to do that much of payload capacity, we can enhance it. Apart from that, you all know that the recent trend is reusable launch vehicle. See that expendable launch vehicles are more expensive one-time use and not able to use it again. Rockets are being one-time use. Around 190 crores of money is being pumped into any rocket of PSLV of a class of rocket, and we are not able to use it again. So reusable launch vehicle is capturing attention. That also technology demonstration we have done, and there was splash landing in the sea. And next will be we'll be landing in Chitradurga. There is a strip getting ready right now, airstrip getting ready. That next will be a guided uh, um, descent phase. Ascent phase was guided actually in the first phase, and descent was not guided actually. It was just getting it landed in Strat and touchdown in Bay of Bengal. Second thing, we'll be having a guided descent phase also. We'll be able to bring it back to the required long lat wherever we wanted actually through airstrip and safe landing. That is a land landing instead of sea landing. That is one thing we are going to attempt now in Chitradurga. We're getting a airstrip ready now for the second RLV technology demonstrator. And apart from that, we are having Chandrayaan 1, Chandrayaan 2. Of course, you must be knowing that Mars orbiter mission also. That is ongoing right now also. Chandrayaan 1 also, Chandrayaan 2 also, orbit is ongoing. All are on now. We are getting data from that. Apart from that, AstroSat, that is unique science experimental mission what we have launched, that also getting a lot of inputs. That is science exploration missions. That also another this one. So we must be knowing Chandrayaan 2, how it captured after escaping from the Earth orbit. You must be seeing that there is a lunar transfer trajectory. It will go for 29 days, and after that we'll be capturing into the lunar trajectory. You can see insertion lunar trajectory and capturing and going to South Pole. That was the, you can see the orbiter, lander, and Pragyan, Vikram, and apart from the lower Pragyan also. And Mars, of course, you must be knowing this 28 days was Mars Mangalan mission. It was around 100, almost 1 year, actually 360 days. And you must be knowing that after 360 days, if you restart the engine in one command, it should start. Otherwise, it will lose. It will go beyond the Mars, and you won't be able to capture the Martian orbit. That was the critical point in that. And even you must be knowing that one auto-shot itself, it doesn't start by kickstart. 1 or 2 start kicks you have to give. So one command which is given 40-45 minutes beforehand from the land goes, travels, and triggers that engine, and we call it liquid apogee motor engine, LAM engine, which when I was in LPSC, the LAM engine was tested and given by me, my team actually. I'm so proud of that. It worked very well. The Kumbhakarna, we call it, it was sleeping for almost 360 days, and after that, when you was just kicking start, it started and working. It was working properly. That was a very important thing. So here we'll go to space 2.20. After this, we'll just break for some questions or whatever you want to ask me in between. Krishna Kumar.
Yeah, Venkitakrishnan, thank you. It was a very, very long reach of what all things are happening in the space technology. So if you have got any questions, you can just have a chat in the chat box. So if you have got any questions, please come forward now. If you want to ask questions directly, you can unmute and ask. Okay, here is one question from Dr. Paul Kola.
Yeah.
Venkitakrishnan, your classmate.
Yeah.
Indians are the best at software application development.
Indians are
so opening up that Indians are the best
at
software application development.
You're fine. Yeah.
So developing a satellite data to private parties, or sorry, opening up satellite data to private parties to create more applications is an excellent force multiplier. What are the schemes being worked out for such innovations in hardware?
Fine. See, today, as on today, electronic devices still we are importing. There is a small slide right now coming in the second 2.0, which gives a kind of whatever area left over in India to indigenize right now also, to import substitution. That's one thing I am going to talk about in space 2.0. So 100% indigenizations, Atmanirbhar and self-reliance we are planning in space especially. Even though Atmanirbhar has started now only, in other areas, space long back itself we have started for self-reliance, because you must be knowing that's very strategic area wherein in a small thing also being imported, not being able to make in India, can put us into problem, and we will not be able to launch the entire, even a strong, very, 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 what you can call ultra strength alloy nut is not there, also we cannot launch it. That is the scenario in the space, and space is not for chicken-hearted people. Definitely, you must be knowing that. So we have taken a lot of risk in the entire of thing, and including testing of engines and all what we have got in Mahendragiri, the test stand, everything. Over a period of time, we have built up a lot of infrastructure, and you must be knowing this. All this infrastructure, what we are right now having, is not being used maximally and usefully by all of us, because acoustic testing facility, for example, we'll be having a testing of acoustic testing and other things, and vibration testing and all, for all these kind of frequency matching of. You must be you must know that in firing of the rocket, there is a frequency coming in the firing, and that should not match with the frequency of your satellite. If it matches, it will resonate, and there will be a kind of maximum amplitude, entire wire and everything will break. So we need to see that it's staggered, and we don't have the kind of resonance happening. So acoustic test facility is one thing where we need to test everything. What is the kind of matching frequency of satellite and matching hardwares, everything. That is being used only for 3 or 4 days or 5 days in a quarter. Actually, the rest of the days it's available. So anybody coming forward from private sector to see that this, but this kind of facilities, if you want to establish, it'll go. It's a very huge capex is involved in that. So you can't actually afford to do that. That is one more important thing. So we need to see that if you are able to. But so far the privates were not allowed because of strategic applications. Because space is having missile technology and dual applications. So now slowly we are opening up cautiously to see that how to see. We need to see that doesn't go to wrong hands also. That is not important thing. So space laws are getting amended. Space Acts is being passed right now. Ordinance will come in another few days. Now we have just charter out, and our office only is doing all these things. We have just charter out and given that. So this is now being discussed in various cabinet meets and all. So other ministerial groups, interministerial groups. After that, now once the ordinance is passed, we will be having a Space Act also in place. Space law will be in place. All this is put together. We need to cautiously open up this entire thing to the private players also. A lot of startups are coming for the space technology application. So there is an interface being made right now, which we'll be talking about in the next 2.0. So these startups who are good in developing these software applications and all, definitely can approach this through this in-space, what interface mechanism is being called, and they will link us with the NSIL, which is a commercial arm of it. ISRO cannot make money. We are not a revenue generating agency. You know that we can't. We are only an R&D organization. So if you want to put it across and audit, and you want to have the balance sheet, everything put together, R&D expenditure cannot be used for making a source of revenue. That's a big this one in that the lacuna in that. So we need to create a separate commercial organization called Space India Limited. Through that we can make profit, and that's a public sector enterprise. So there is a mechanism on place right now. Let us see how it evolves. Actually, I can't predict right now itself how it will be evolving, but the entire idea is to open up to private to see that the entire space technology is used properly in India. You must be knowing that digital India has picked up like anything, and almost we are going cashless and paperless now. Almost in the COVID has accelerated the entire thing. Thanks to COVID, in some sections, I should always say that even though we are suffering in technology, we are leapfrogged much beyond. You must be knowing that we almost digital play and cashless world is emerging right now. It's accelerated like anything in the and COVID scenario, and post-COVID will be actually another force multiplier for us also. So this definitely, as you told, is a force multiplier. We are waiting for the entire thing to happen.
Krishnan, Geeta Menon has a direct question. Geeta, you can unmute and ask.
Yeah.
Sure. Hope you can hear me.
Yeah, I'm hearing.
Okay. Hello.
Hello. No, I'm not hearing you.
Yeah, it has gone unmute. It has gone
mute. Please unmute.
Sorry?
Yeah, please unmute. Yeah.
Can you hear me now?
Now I'm hearing.
Okay. I really enjoyed your presentation. It was very interesting, and especially the passion with which you were talking about space.
Yeah.
The thing that I wanted to say was I'm very happy to hear that all the work in terms of the work you're doing, that you are more focusing on applications, not just space, launches and things like that, but more things that are useful for India, and that's great to hear. I heard from you that your one challenge was that Mangalian, that kickoff and timing it perfectly. But what I really wanted to ask, and maybe also for the benefit of GECT and those who are looking forward to a career in a space organization, is what is the most satisfying thing as far as your job is concerned? I mean, I'm not asking a technical question here. I'm asking what is it that drives you in terms of your job?
So Geeta, I will tell you in two simple words. Actually, I think you could be able to appreciate. I don't want to prolong the answer. Actually, full freedom is given to you. That is one thing important. You can have full freedom of your thoughts, and you want to develop something, and full freedom and money is given to you. That is one thing. There is no hierarchy actually. You can cut across the hierarchy and go to anybody and seek help, and they'll be happy to help you. And if in case you're going very fast, you are not able to accommodate in the conventional system, they will create a separate post for you to see that you are accommodated properly and you are also honored properly. So you will be enjoying the work here definitely. If you are serious enough to see that, if you are also passionate, you'll be enjoying the work in ISRO. And there's a great ISRO culture, what we call it, review mechanisms and all. You can participate anywhere, and you can air your views. All these things are possible. So the review mechanisms, right from new entrants are given a lot of importance in ISRO, and they will be hearing them properly. You can stand up on your leg and air any question or any doubt or any point you want to make, or you want to tell anything new. Also, you'll be heard properly. You'll be allowed to make presentations. You'll be encouraged and appreciated. These are important things in ISRO. What is happening, which is not there. I believe, I don't know much about the other organizations. May not be there, as I hear from others, that these kind of things are not happening in other organizations as I communicate with them or I get transfer with them.
Okay, thank you. That was a great answer. Great to hear that as well. And I hope if that works for ISRO, that other institutions, organizations in India start following it as well, because that's definitely a good environment for working in. So thank you.
Yeah, and we feel the ownership actually. Anybody in ISRO doesn't behave. If you don't behave anybody properly, you will feel hurt that I am hurting ISRO. There is an ownership of ISRO for anybody who is an employee there, right from the top to bottom. Okay.
Thank you.
These are two important things. Okay, Krishna Kumar. Then if there are no more questions, can I go 2.0?
So I think proceed with the second.
This is Space 2.0. You must be knowing it. It was in the news in the last when Nirmala Sitharaman, Honorable Finance Minister, declared that the space reforms. It was in news for quite some time, and now also it's news, and we are now making the in space into place, as well as the mechanism into place, and we have started accepting the applications right now, even before start of the in space mechanism itself, and we have got around 250 applications already piled up with us for a lot of interest being shown in the opening up of space. And space is going to be one important business in the years to come, space business, and it's a new opportunity actually coming up, because without space nothing is going to happen in future. I'm telling you. You must be knowing by now itself that without mobile, without space, you must be knowing that nothing is happening now also, because even ATMs, tele-education, telemedicine, everything is now whatever you see, everything is now through space only happening. And there are a lot of opportunities are there in the development of softwares for all these things, like your mobile apps and ATMs also. Different softwares are being made for ATMs also. A lot of opportunities are coming into picture. And the evolution is the only constant we have kept in my mind actually, that you must be knowing that is the only thing constant in ISRO. Evolution continues to evolve. That is one thing important. New institutional mechanism like NCL and as I spoke sometime back, New Space India Limited has just now started in space, International Space Promotion and Authorization Center, for which a secretary grade chairman or a space secretary will be there. And that will be the interfacing mechanism with private enterprise as well as other players, non-ISRO players, to see that what they want to do with ISRO facilities. Our facilities are open to public now. I don't think you will be charging them much more, because the capital expenditure already made. We will be only charging the marginal costing actually. The maintenance cost only will be charging, because already the infrastructure is made for Indian space program. So we don't want to amortize the entire capex into their fees, what is going to charge from them. So we need to see that what best we can do for them, to see that only the running cost as well as the maintenance cost is taken from the users, and we are going to throw open the maximum possible facilities in India, in the like thermovac facilities, like you can call vibration test facilities. All are very clean rooms. All are very capital intensive facilities what we have created, will be available for private players also right now through these in-space mechanisms, and through a kind of costing which will be handled by NCL India, so that the entire of profit what they made will go to NCL India, and ISRO will not be coming as a revenue generating agency. Space law updated policies for navigation, remote sensing. The entire of communication also, the frequencies, everything is given by a kind of a separate body called Frequency Allotting Agency in the central government itself for satellite communication. So frequency, private players are coming into what kind of frequency are to be allotted to them. Everything will be debated there, and will be interfaced through in space, and we'll be allotting it that also. So small satellites, if they want to launch, they can come and launch. They can make satellites, and we'll be able to launch. Small satellite, we are going to get another SSLV, small satellite launch vehicle also right now. We are going to have it now for 500 kg, less than 500 kg satellites in LEO orbits separately. We don't have to spend the entire force of PSLV for that right now. So this is one thing which is happening. ISRO to focus advanced technology. We will be focusing on the technology development and deep space missions and science space missions and Gaganyaan in the years to come, and capacity building in the space domain. That also is another vertical what we are right now having, which I am heading right now. New Space India Limited, a few words about that. See, it's a central public sector enterprise under DOS, demand-based model, aggregator of user requirements and obtain commitments. It's a kind of demand-driven model actually. The entire thing will be driven by the demand what is coming from the user community and stakeholders. Ownership of operational launch vehicles, the entire ownership of operational launch vehicles like PSLV Mark II and GSLV Mark II and Mark III will be handed over to them. And productionization through industries will be handled by them. ISRO will not be into production of launch vehicles right now. The entire thing will be handled by NCL, and we will be only into R&D, entire R&D. We will be focusing on R&D to see that we are leapfrogging and able to match with others in the years to come. So that kind of a channelization will really make us focus into more of advanced technologies. That's what the entire idea. Commercialize the launch vehicle, satellites, and services, and those who want to come from private also will be allowed to enter into. And Indian National Space Promotion Authorization Center, the new one which is being created right now under autonomous body under DOS, Department of Space, single window nodal agency to coordinate and enable private sector participation in space domain, sharing of technical infrastructure facilities, and intellectual expertise. You want to have some intellectual expertise, hand-holding from our side also will be available as consultant, and we'll be charging a minimal charge for that also. So entire expertise available right now to see that more and more people are entering into space and space arena and space technology applications, to see that the entire country is being benefited, including rural as well as semi-urban and urban. Announcement of opportunities for private sector also will be coming in our launch site, our website and all. Integrated launch manifest. So we'll be having integrated launch manifest. We will be giving land also if you want in Sriharikota. Land is available. If you want to have a private launch pad also, you can have it. That is another one we are going to have. To that extent we are going. And ISRO, NCL and private sector put together will be having integrated launch manifest for the coming years apart from ISRO. So far we are having only for ISRO. So total complex consolidated integrated launch manifest will be prepared by InSpace, and that will be implemented. The future trends and activities what we are going to do in R&D, ISRO will be concentrating on technology demonstrators of these things. Whatever I am showing here right now in one slide, uprated cryogenic engine stage. We are having C25 right now. We'll go to cryogenic C32. And we are having a stage of 20 tons propellant right now. We are going 22 right now. So these are all things which is possible with the existing thing itself without changing the diameter or dimensions. That's why we are going 22. If you ask me why you are going 25, 30, that will call for again configuration change. Without changing the configuration, we are going to have maximally utilize the existing configuration, that is C32, that is 32 ton. From 25, we are going to another 7 we are going to add, and 22 is that stage propellant mass will be going from CE20 to 22, another 2 tons we are going to add. And the L110, that is liquid engine 110 will in the of Mark III will be replaced by this particular thing what I told right now, uprated cryogenic engine. That will go to 6 tons to GTO. That is another thing. Apart from that, we are going to have recovery experiments also, advanced missions. At the L40 stage of Mark II, L40 we have got 4 strap-ons in Mark II. You must have noticed that. One of the strap-ons we are going to have some of the experiments right now, advanced missions and recovery experiments. These stages, these are for reusable stages. These stages, you must be seeing the SpaceX and all, I will be able to again bring it back and recover it and refurbish it and reuse it. So stage, if you are reusing the expendable launch vehicle, a lot of cost we can cut down, and we can cost also can be cut down if you are able to reuse the stages what we have made with a lot of investment and money, lot of resources. So advanced missions, so to see that we are able to recover the stages and refurbish and reuse it. That's called ATMER. That is one of the another thing what is right now in the offing. Apart from that, we are having blocks, liquid nitrogen gas. So liquid natural gas, methane engine. That's one technology demonstration that's also going on in our Mahendragiri. When we are going to man-rated LV launch vehicle, triple modular redundancy, what we call it. No, we will be having. See, the reliability of this man-rated vehicle should be very high. So we are having dual redundancy right now. Everything very critical. Single point failure points are we having two numbers right now. All the critical things to see that redundancy is passed. Now we will go to triple redundancy. One more will be added now to see that the human who is traveling in that is very safe. They're called triple modular redundancy, TMR we call it. That is the change what we are going to make from the Mark III, what right now we are having, to man-rated LV, we call it man-rated launch vehicle. And we have got in semi-cryo also. Once it is developed, we will be having a modular launch vehicle. We can have any type of strap-ons and any type of core vehicle. We can select from that and attach it and launch it also. That is one more thing we are going to have. And right now I have talked about this small satellite launch vehicle, which will be coming in the 2021 first quarter itself to have payload capacity. And here now you are having another second launch pad also, which is coming in Kulasegarapatnam, right now little more south of Sriharikota, on the eastern shore, coming down near Tuticorin. Because this spend stage will be falling in between. So if you use the Sriharikota range, we won't be getting maximal benefit. So we are coming down a little more to have some more. And this we are expecting that a lot of countries will be coming forward to have commercial launches from India once you are able to, because this we are having to have checkout system in a laptop only. Checkout system, integrated systems and all, it can be integrated in 3 days. It is like almost like call taxi. If you order today, you can have the launch day after tomorrow. That is the kind of thing what we are envisaging. And reusable launch vehicle and orbital re-entry, these are the 2 other vehicles, which are hypersonic vehicles. Not the other one right now what we are testing is supersonic. Now we are going to have hypersonic also, which Mach number more than 5 or 6. And usable launch vehicle, orbital re-entry also we are going to plan, which will be having 2 stages to orbit. So 2 stages to orbit. First stage is expendable and second stage will be re-entry. That is the thing. So it will be low cost access to space in the years to come, so that we'll be able to bring down the cost of launching and to attract more of satellite launching from outside. We are one country, you must be knowing, that having a launch capacity as well as satellite making capacity out of 6. So the 7th one has not come so far after my joining. 6 was already existing when I joined. So for 37 years I completed in ISRO. The 7th one has not come so far. So it all shows that it's not so easier thing. Vikram Sarabhai started in the right time. We are into this and we are able to progress this very fast. And we are supported by the entire government. Whoever is coming in, we are being supported very well. That's why we are able to proceed further in the whatever direction what we want. And this Gaganyaan, just one slide. I just wanted to show you that what is the kind of advantages what we are going to have. Inspire the youth to have science, technology, and engineering and maths, STEM. technology spin-offs. We get a lot of spin-offs from this, including the kind of space suit what you're going to have. A lot of things can be made out of that also. The material development what you're going to have is enormous actually here. More than 170 materials we are developing for human space mission, which can be used for many other purposes or other spin-off technologies also. Human resource development also, ample scope for training, international cooperation also is there, spur for research and development, stakeholders, institutes, academia, and industry, improve industrial capabilities, and we'll be leapfrogging in industrial capabilities like anything as we have done in the past. The HSP will actually make it double a force multiplier, as you can call it. This is a small slide which I'm showing to you in 400-kilometer LEO orbit. We are now planning 5 to 7 days with 3 people inside the crew module and separation module. You can see the crew module re-entry, aero braking, and parachute deployment is splashing down, and we are recovering that particular module. And after that, we'll be having here we are concentrating on completing our 6 to 7 days in space and coming and returning back. After that, we'll be having a separate landing, which is coming in the land itself, and we are able to not in sea. The second phase will be that actually, and this will eventually lead to a space station development, docking, and all in future. Okay, we'll be into that step by step. And Indian space program future trends, you can see that high throughput satellites are going to come, geo imaging is going to come, C-band SAR satellite application, synthetic aperture radiometer radars are coming to come, earth observation technologies are going to have, and high resolution and satellite constellation is going to have. We will be having constellations instead of one single satellite, micro and macro satellite constellations. A 13-band ocean color meter also is going to have, and 25-meter stereo, that is for the your image processing software. So all these things are going to come in near future. These are the future trends. Actually, you can see the bottom line, Chandrayana 3 2021, Aditya 1, which is one of its kind in the entire world. We are going to have Langagre point, which is very near to the where we can go maximum nearer to the sun to observe the sun from a distance. The nearest point where we can safely go, we are going that Langagre point L1. We are going ISRO 2021. And you can see that MOM mission is also 2022. Apart from that, we are going to have the Venus mission in 23. Lunar Polar mission again, South Pole mission, we are going to have repeat in 24 with soft landing, and EXO Worlds, that is the most exciting science mission we are going to have to go into much more deeper into space to see that the entire of universe and your solar system is being explored and more uncovered. So this is one thing which we are going to have. This also, the paperwork has started already. We'll be concentrating on these things, and commercial launches by NCIL, and private also will be coming in with the resource sharing. So I hope we will be able to leapfrog in the years to come, and we'll be able to match with any other country in the space arena. And this is the kind of verticals right now. We are having space applications. We are having one vertical, space infrastructure, that is satellites, and space transportation, that is rocket, and capacity building headed by me. That is the one thing which is going to have these kind of reforms, and all these things are taken over by my office. And you can see the technical infrastructure, academic, industry interface, outreach, and human resource. Everything is handled by capacity building office. And coming to what all things are in the offering for the research scholars and students, this will be of interest to all students who are JCT, who are aspiring for a future in career in space, not in ISRO, but now it's all open to public outside also. You can have a career in space, not in ISRO itself. You can have from outside also. That is the idea what I want to sell here. So we should systematically carry forward the capacity enhancement plans of organization related to infrastructure, human resources, and interface with academic industry to ensure implementation of short-term and long-term programmatic goals in a seamless manner through progressive policies and procedures. That is the vision of my office. This is almost all what is going to happen in 2.0. You can see the kind of other things what we are handling right now: skill development, IPR, startups. We got a program called Space Entrepreneurship and Engagement Development Program called SPEED for startups, which we are giving 2 crores to a startup if they are qualifying through our mechanism. And outreach policies, so we are having space parks and other things, technical infrastructure. You can go academic interface called Space Technology Centers, Spectrology Incubator Centers, Regional Academic Centers for Space, National Application, National Academic Partner and Respond, Sponsored Research Respond, Industry Interface, and a lot of things are to be indigenized right now. That also is available to take up as any kind of startup activity. You can see this academic interface Right now, we are having this much of academic interface happened under capacity building program office. We are going technology incubation centers right from Kohat University to Agartala and Kharagpur. You can see the entire of India we are covered, and almost all. And you must be knowing that NIT Suratkal, and I have just put a small boundary there. NIT Suratkal and NIT Trichy are the ones which GCT Trichy are supposed to contact for incubation center and as well as academic activities. Two types of centers what we have started is, one is for to nurture the research attitude of the students actually and the student community. That is the regional academic center, which will be having more of research oriented projects, and the incubator centers will be having more of product oriented research, actually applied research, and more of product oriented. You'll be having some kind of innovation or modification for the existing product itself. That will be giving us a challenge. That is that center is in NIT Trichy for you in for GCT Trichy, as well as the research center is for Suratkal. Actually, you can contact them. You'll put a word to them so they see that you are able to link with them and able to get some kind of projects. Yeah, there's no upper limit. Any kind of projects which is passing through our system, will be funding it. You can channelize the fund through these two sources actually, NIT Suratkal as well as NIT Trichy. You can see the other centers actually. It's all 6 regional centers. One is for north, one is for south, one is for east, one is for west, and one is for northeast. Put together, there are 6 regional centers, 6 incubator centers, and entire of the country is covered under this program. And we have one Jammu Kashmir also, one Satish Dhawan Research Center for avalanche and other Himalayan belt studies. Apart from that, we are having a Veer Surendra University Innovation Center also. That is one innovation center. Other one is all incubator centers. This one is an innovation center actually. You must be knowing that. So these are the academic new ventures what we have started right now. It is already started funding. You can see another important slide is that industry, we have indigenous 9.7% of launch vehicle only need to be indigenous right now. We are almost indigenized around 90%. You must be 91%. You can say that 98, 92% from this. Out of the 9.57%, what is remaining to be indigenized, you can see 18% are bought outs and O-rings and other things and all. O-rings and all. These areas are available for indigenization. Chemicals are 1%, materials are 38%, electronics instrumentation 39%. So our office is concentrating to see that these also is indigenized, and there are people coming forward to see that these are all made in India to make us Atmanirbhar. Apart from that, if you go to satellite, you can see GSAT, one typical satellite I have taken, 50.49% is yet to be indigenized. Out of that 50.49%, you can see the kind of pie what we have now. 1% is composite and iron thermal, 2% like that. I got a sectorial pie there. You can see that people can pick up from that in your domain expert area and start indigenizing, and we will be able to buy from you. There is a buyback policy. Ab initio itself, in the beginning itself, we'll be signing with you to see that your market is ensured. This is one thing what we are going to right now, and we are having these kind of interfaces, mechanisms, spacetronics we are conducting every year. It's full of, and we are going to have one pilot fab. Those who are going to make device in India, Paul Kola has asked something. What is the kind of plan you are going to have hardwares in India? You know very clearly that we are not much good in hardware making in electronic hardware making, device making in India. Semiconductor lab, we are having BL, we are having. Apart from that, ECL, Electronic Corporation of India, limited to ACL, we are having. These are 3 institutes which are involved in making components and electronic devices for India. In that itself, the ASIC foundry is not at all there. We have got 160 nanometer one ASIC foundry. We have imported from Belgium. We are going to have now. But the kind of scenario right now is the 30-35 nanometer. We have come down. We are reverse engineering it and seeing that how best we can see that how we are the other one 30-35 nanometer ASIC foundry. We are able to make it in India itself. Once that is coming through, you cannot have 5 nanometer, 6 nanometer and all in space, because radiation heat will be coming and you'll be having a kind of short circuiting. So the trade-off what we can have is 30-35 nanometer short ASIC foundries we can have. That is the kind of thing size we can go in space. Beyond that, if you are able to miniaturize it, if you are able to, if you want to miniaturize it also, it's not possible because radiation heat effect will be coming from the space. So another thing is that radiation barriers we should be able to make. If you are able to make good radiation barriers, radiation shields you are able to make, We can go up to some more miniaturization up to 5 nanometer. Hope I am able to convey the message to you. So these are the kind of challenges right now available for the researchers in various applied research as well as basic research areas. And apart from that, we'll be having a catalog of almost all what is right now to be made. And PSLV, of course, is going to be through a consortium. You must be knowing that we have GOCO model, government-owned and company-operator models, where facilities are going to be operated by private party from outside. We'll be giving training for them, and if you want to operate the facilities also, you can have an opportunity to operate, and that's also going to be a business within ISRO and through industry also. Industry is also opening out for GOCO models and all because of the numbers which is going to increase in years to come for launches and all. And 3D printing summit we are having every year to see that how many of our components are made into 3D printing. Able to make it into 3D printing if it is economically viable. And last year we had a UK industry space meet, and next year we'll be having another country like that. We'll be having country-specific industry meets also in the years to come to see that where we are able to cooperate also, and MOU are ahead to demonstrate. Industry technology transfer, a lot of technologies we are transferring. That also is another important field for people to pick up and start working. And we'll be having a buyback policy also with these industries so that your market is ensured. So these things, whatever you are able to take up from ISRO, we will not be making further in ISRO. We'll be depending on you. You can see that kind of TT agreement signed so far with PSUs and government. The pie is very clear here. And how many 2019, the last 4 or 5 years, I given a kind of bar chart also, how many technologies, around 350 technologies we have transferred. That also for a very, very minimal license fee of around 10 lakhs, 15 lakhs. You won't be charging you the infrastructure cost at all. We'll be only charging you the marginal costing. That's the advantage you are going to get. And it is non-exclusive. You must be knowing that there's no exclusive technology transfer. It will be non-exclusive. It will be giving for multiple players to see that more people are getting advantage of that. And this is the industry is engaged in the technology transfer so far. You must be seeing all India. It's almost all India spread. Just to give a flavor of that, what is happening, technology transfer and spin-off technology, what we are going to do, what we are given so far. And another 120 more technologies are available right now. It is on the annual. We are trying to make documentation and going to put it in website right now. It is available to take any startups or any industry or anybody who can want to make, including softwares also we are going to give out, so that those who want to work from home also, so small industry and all kind of thing also is possible now. So Atmanirbhar Bharat, any arise challenges we got with adult new India challenges, Atmanirbhar Bharat, the combination we got three areas now: propulsion, geospatial information, and robotics and AR VR. We are having a startup funding right now. 50 lakhs will be given in phase 1, 50 lakhs in phase 2. Two industries in each. These 3 areas. So we'll be having two industries each, which can bag 1 crore for seed money, and we'll be having a buyback policy also with them. Apart from that, we are going to have independent, not with collaboration with anybody, space enterprise and encouragement development program seed, which will be given, which is on the annual right now. We are going to Space Commission, which will be giving a competitive, early stage competitive program for startups, which will be giving 2 crore seed money in phased manner as they progress along. Apart from that, business opportunity space is being consolidated. Documents will be available on our website to see that what kind of business you can have with space as well as space technology development. This is outreach and international cooperation we are having. Yuvika is, you must be knowing that it's a kind of school children program. It's a contact program. What we started to see that more and more students are being attracted to science and applied science and science research programs. And we have got Space on Wheels, which is going around the country, entire of rural areas also. See that in 6 regions, demonstrating the kind of space power and space technology applications, make people aware to see that more and more people are attracted to space technology area research as well as space applications. And we had the Sikram Sarabhai Centenary program, year-long program, just concluded right now with a massive outreach. What has happened? We are trying to get into Guinness Book actually, but governmental facilities will not allow us to get into a huge sum has to be paid to these Guinness Book authorities, which was not allowed by the Space Commission. So that such kind of things we need to spend money. They told we will not be able to. But what I want to stress upon here is what's a massive outreach program actually. And these are the initiatives on the skill development program also we are going to have, which is fully free in 7 trades right now. We have started, including the space quality welding and space quality CNC machining and all these kind of things, fully free, funded by ISRO. Residential program, 20 in each trade, 7 trades, 140 right now, 140 per year for 5 years. Right now we are going to entering into a contract with a private party here, which will be a 1 month residential program. It will be a certification program. Once you get it, you can get into any of the aerospace industries which going to come through this in space also, apart from ISRO. And it is being imparted by Aerospace and Avionics Skill Council under Ministry of Skill Development. And opportunity for National Space Academic Partner. One domain-specific area, one academic partner we are taking from one institute. We are taking as academic partner. Any research in that particular area will be given to that particular institute only. You won't be having any investment in ISRO. The entire money will be pumped to that institute, and institute will be developing that particular area is also. Apart from ISRO getting the benefit out of that. Socio-economic impact analysis, and there's another thing what we are going to make right now. What is the impact what we have made in ISRO by the society so far? Nobody has done it so far. We are going to make it right now also. That is a big, huge survey going on. From that also, we'll get a lot of opportunities. What is the idea is to see that we are able to get what area we need to develop, where we are lacking from that. That's kind of a retrospective thing what we'll get from this particular study. Is another area where space tutors. We have space tutors, promoters, and we will be funding them. Space events will be funding them. Space clubs will be funding them. Schools and colleges. Space exhibitions also will be conducted. As galleries are going to come, and e-galleries and electronic galleries are going to come. And space merchandise is another area where we are going to have all kind of merchandise like T-shirts and other things and all. Which a lot of startups are coming out now, which was not so far. ISRO has not done it so far. NASA has given free of cost their theme, their logo using and all, which so far ISRO has not opened up. Now we are opening out through these space reforms. Is the other business, a big business coming up this area also. Any type of merchandise what you want to have, we can make it with a small license fee. Thank you so much. I think I have taken up some more than time what is expected out of me. And thank you for patient hearing. Any more questions? I am most welcome. Thank you so much, and all the very best. And I would like to see that more people are interested in space research and space technology application area, and we'll be able to provide you with satisfactory answers and all your aspirations, whatever you are looking for. I hope ISRO will be able to fulfill it. And all the very best. And thank you so much.
Thank you, Venkitakrishnan. There are many questions, especially based on the big expansions and big projects.
Yes.
So there is one remaining, which is tail end of the previous session. It's by Nandakumar.
Yeah.
The last 15 minutes of Chandrayaan 2 was a failure.
Yeah.
So what are the lessons learned? Because even after that, you are expanding into too much of different areas.
No, I will tell you exactly. I think all our technical people. So see, the soft landing. The very word soft landing is a very tricky thing. The lander should come and there should be soft touchdown. The velocity should come to zero almost when you are touching down. So we were killing their velocity in a delta manner there was a phase called rough braking. You must have seen in the TV. After that, we are going to a soft braking. The propellant mass is continuously depleting. The propellant is continuously depleting. The thrusters are being fired in the opposite direction of landing to see that Newton's third law is applicable, and we are able to retard it to the extent possible. So there is a continuous usage of propellant mass continuously changing. So thrust what is developed should be continuously changing. There will be it should be continuous throttleable engine. A continuous throttleable engine we were not able to make. I'm telling you a fact. So we have gone into step by step. We have gone into 40% throttling, 60% throttling, 80% throttling, and 100% throttling, and making it to zero velocity. So we are going in steps instead of continuous throttling. Hope you understood. So in the say 60 or 80% throttling, what we are trying to plan, the throttling was not sufficient actually. So it was having a velocity more than expected actually. It was continuous throttling was not possible by us because technology is not developed to that extent. So we are going in quantum steps of 20% each. We're trying to experiment that and see that. Now in the Chandrayaan 3, now what we have learned is actually when it's coming to 2.1, we are so dot on spot actually up to 2.1 kilometer. Beyond that, the velocity was slightly more than what we expected. And there was a small control and guidance problem in that. The closed loop control was not working properly. And there was an algorithm. We are not tested to the extreme ends. In fact, that is one lesson we learned. And we are going to perturb the engine to the maximum limits now in the third whatever you are going to have. So the last phase velocity, whatever was supposed to have, are having a more velocity than expected, and it came and hit rapidly from 2.1 kilometer onto the surface of the lunar surface and got damaged. So that was that up to 2.1 kilometer. When it went very softly, we thought it will go in soft land without any problem. The kind of technology what we have conceived and implemented was sufficient. We thought now we have to go for little more discrete throttling. Actually, 10% throttling in the next mission. Actually, instead of 20% throttling. Hope I am clear and it is clear to all of you.
Yeah. Now the next question is from Professor Manoj, Professor of Computer Science. Many institutions are launching satellites. Is it possible for GCT to launch one?
There's a launch. There's a satellite launch, student satellite launch program office in URSC. There is one Mr. Kannan who is in charge of that. If anybody is coming to, you have to first approach this capacity program office, my office, and you'll be channelizing to them. And once they are through, all the facilities like thermovac facility, your vibrant test facility, or capex facilities will be given to you to make it, and you'll be having hand holding orders to you. But you must prove that rest of things you'll be able to make it. They'll be what kind of interaction you are going to have with them. You should be able to instill confidence in that the rest of things, whatever you are supposed to make, you will be able to make it in the right time. So once you are making it, we'll be launching it one of the PSLV as a piggyback, like what you have done in the past, and your satellite is in the orbit then. Okay, that's what we have got a program, student satellite program. It is on already. You can see the website.
Yeah, I think the college is also going to launch a mentorship program.
Yeah.
And this could be one area where the students can participate and deliver.
Definitely.
In fact, we had a space club in the college.
Yeah.
Way back in 2010.
Yeah.
It worked for about 3 years, but then it had a natural death.
Okay.
So I think using the mentorship program,
yeah,
the college can come back to that idea. So next, there is a question from Professor Sajikumar.
Yeah.
He is a professor of civil engineering.
Okay.
We are really proud about the achievements in ISRO.
Okay.
He's a user, Dr. Sajikumar is a user of satellite imagery.
Okay, fine.
I feel that the policy on data needs to be liberated a little more.
Now, in the
For
coming
example,
reform, it
foreign
is
satellite image, Sentinel-2, MSS are freely downloadable.
No, what I want to answer in one single sentence is that it is going to be fully free now. Okay. It is going to be fully free now. In the recent reforms, it has been made fully free, no charge at all. Okay. It is going to come now in another couple of days.
So is it, I think Dr. Sajikumar had a problem in getting some of the data.
I think through you,
one of his previous.
Through you, he contacted me, and we had that
yes.
thing was actually a sensitive thing which could not be given. So any non-sensitive data which is not hampering the country's interest, now it will be available free of cost, and you can download it without any cost. Now, so far now you are nominal charge to NRC. Now that also is not there. You can give it. You can have it now free of cost.
I think Dr. Sajikumar, you can contact Venkitakrishnan directly.
Yeah.
For any of your feature needs.
Sure.
I think your query is satisfied. Now another question from Muhammad Aslam about the opportunities for student startup. I think Dr. Venkitakrishnan has already introduced a few topics in that and few leads into how the students can reach the correct person. And what I feel is the second part of your lecture, the phase 2 part, should be elaborated at later stage, depending on the requirements from the teacher side.
We are just waiting for the entire thing to evolve. See, it's all demand driven. It all depends upon what kind of demand is coming from the cross section of the industry and startups.
And there is one question from Professor Ajay James. He is in charge of the entrepreneurship development cell of the college.
Yeah.
At present, ISRO doesn't have an incubation center in Kerala. Why don't you give a chance to GCT?
No, as a policy to start in the beginning itself, as an initiative to start itself, we have gone to centrally funded institutes as a policy. There's a policy document available right now, which is saying it's centrally funded institutes. That's why you go to NITs. The IITs are having space technology cells. We call it STC. A separate package available from the very beginning itself. Now we are expanding into a little more IITs now. So earlier it was available only to Kharagpur, the old 5 IITs. Now new IITs. Now we have started. You've gone to Roorkee, Guwahati, and Mandi also now among the new IITs. So another 3 more IITs are added to STC. But whereas NITs were not available anything. So we need to go to NITs as second phase, centrally funded institutes. And we have created regional mechanism, southern region mechanism like that. The entire of colleges available in southern region can channelize. You need not feel that you did not get independently one incubator center or research center. You don't feel have. Sometimes no, the center in Suratkal will not be having more. Sometimes they may not be having more projects. You can channelize more projects through. See, it all depends upon the merit of the project. Any college in the southern region, in the Kerala, Tamil Nadu, Andhra, Karnataka, and Pondicherry, Lakshadweep, and Andaman. This including 2 union territories and these 4 or 5 states, any college, any private or public, anybody, government, anybody can have a project through this particular STIC in Trichy as well as RACS. Depending upon if it's a product development, you can go to Trichy. If it's a research project, you can go to Suratkal and channelize through them. It will reach us. If it is meritorious, if it is worth pursuing, definitely you will be encouraged. Money will be coming through them. The money will be handled by them. We want a mechanism to see that money dispersed is utilized properly. For that, we are now banking upon centrally funded institutes. Through them, the money will be given to you, and you can tap it and use it, no problem. Don't have the kind of feeling that you are not having incubator center, because we can start like this only right now with the kind of resource what you're having. Maybe it may be expanded in future to others. Each state separately one each in the years to come. Maybe in the later phase.
Yeah. Thank you, Venkitakrishnan. There is one question from Atira.
Yeah.
What about the research going on in the reusable launch vehicle category? What technology can we implement to develop reusable launch vehicle?
See, reusable launch vehicle right now, what we had was having a controlled ascent phase. Controlled ascent phase. It was a horizontal takeoff. It was a vertical takeoff. Vertical takeoff and horizontal landing. In the future, it will be a horizontal takeoff instead of vertical takeoff. It will be a horizontal takeoff. So takeoff, it will be controlled ascent phase, and the descent phase. What we were having in the earlier experiment, what we had demonstrated a couple of years back, was a free, unguided descent phase. Now, in the next technology demonstrator, will be having guided descent phase also, with control and guidance coming into picture. The gliding, everything will be happening as per our vision will, and we'll be able to bring it to a strip what we are constructing in Chitradurga in Karnataka. So that is a guided. So guidance algorithm. What is required for descent phase? Everything is under development right now. We can have academic institution also part of it. So all academic institutions, the IAC is contributing to the descent phase algorithm development right now. Aero department is like that. Anybody who is coming forward, you can see for announcement of opportunities coming in the ISRO website on all these projects. Right now in a human space mission and the space flight mission, 120 research projects are available in research areas are available for in the human space mission, and the announcement of opportunity. If you can go to the HSFC website, and you can see that it's still on. A lot of responses are coming. So these are all avenues available. Only thing you need to constantly watch the ISRO website continuously. almost every day if you are interested in doing research projects with ISRO and space area. This satisfies. Am I right? Okay.
Yeah, I think
Yeah.
the query is clear. Hello.
Hello, I'm hearing. Yeah.
Yeah, there is one Vandra. Yeah, I'm working in a private industry as a researcher. Being fond of ISRO, how can I contribute to your missions? The very vague question, but still.
The entire crux of the thing what we discussed now is to empower and envisage private industry also as a partner to ISRO. So all the areas of space technology applications. For example, I can tell you there is one project from Agartala in Tripura, the arsenic content of groundwater. So what he has done is he has the entire of Tripura he has made into grids, small rectangular or square grids. And everywhere he has dug some 25 kilometers, 25 meters, 30 meters down, and he has taken sample from that. And arsenic content is measured. And with a new application in mobile, he has put. If you go to any long lat, you get a position, GPS position that he has fed that this particular data into the application in a server. And if you want to buy a piece of land there, if you want to see the kind of water quality, you want to see the kind of the water quality, what is kind of arsenic content there. If you go with an application with your mobile and stand there and just put that particular application, touch that application, that particular long lat is coming, the corresponding arsenic content long lat for that particular long lat is already fed in the computer. It will display that how much of arsenic content is there. And of course, this arsenic content is not constant every year. It will be counting on changing, and water level will be continuously changing, water quality will be continuously changing. And that is going to be another work for somebody else to make continuous data every 6 months. So a lot of opportunities are available. If you can just think of a lot of the limit is the thinking. Actually, you can have any number of projects, space-based application process with GPS, with communication signals, and with remote sensing data. It is limitless. The entire applications are limitless. You can have what kind of projects possible. No, a lot of opportunities are available. Avenues are available. People are coming forward with very innovative ideas.
Question from one query from
Dr.
Jason Matthew.
Yeah.
He is a faculty from electrical engineering department, and he is in charge of the research scholar wing of the college. So can you please elaborate on the respond projects by ISRO? Is there any limit on the funding? And what are the types of proposals supported by ISRO?
To be very frank, there is no limit of funding. It all depends on the quality. There are research projects which is more than 1.5 crore going on right now. So that I can tell that much. Okay. If it is what beyond that also, but only thing is now, as in the past, there's a small change in the future what we are going to bring in. Earlier, research projects were actually mooted and originated from the academic partners. Now, no more is available because we are finding that many of the projects are not getting linked up with the practical ongoing projects. So we are going to have a response basket. Already, we had a response basket last year. Every year, we are going to put a response basket. Whatever is the research projects of interest to ISRO with the principal investigator name, the money, the cost part of it, and the time frame, everything is already made into a project, and the entire details are put into a response basket. And the second response basket is coming in this November. Once it is coming, we are trying to put it 100 numbers actually for every year. If 100 numbers are not available, whatever is available, we'll put it. That is a project already available. From that project only we can take now. Okay, the money also will be spelled out very clearly how much money in that. If you are able, if we are going to make the research competitive. If more number of people are coming for one single project, then we will evaluate the capacity of the institute. One team will visit and see that how best which institute can do it better. Then that institute will be rewarded. So now no more proposals to be coming independently originate from the institute and academic institute. Now we are going to have a response basket. You can pick up from the basket only. That is one area. Another area is research area document. There broad areas are given of interest to us. There you can formulate projects. You got the freedom to formulate project from research area document. From that area, you can formulate a project and you can submit. And if it's interesting in that particular area of interest to ISRO also, where we have to develop certain things and capabilities, and you are able, your response is quite good in that, we'll be able to pick up from that and able to fund you also. There's no limit for funding. It is open-ended.
Yeah. I think Dr. Jason can be in touch with Venkitakrishnan, and he can make the project proposals more easier. Is that okay?
Okay. Yeah.
Yeah. Then
sure. Thank you, sir.
I think there's a
Krishna
there is
Kumar,
an-
Professor, what I want to tell, unfortunately, the number of people who are coming for Respond project and all from Kerala are very less. They are complaining it is not there, but I am not finding any application coming from any of the colleges from Kerala. No, very minimal only. Kochi University have got through 1 or 2, and Trivandrum Engineering College 1 or 2. That's all.
Okay.
Otherwise, no other college come forward. Not even a single application is made so far.
I think we can arrange another pure session in which Venkitakrishnan can interact with the research team.
Yeah, I'm available exclusively for our college because I'm so much interested in somebody is coming from. I'm exclusively available for the college. Okay, no problem. Yeah.
Yeah, Jason, can you do that?
Yeah, sure, sir. Thank you very much. Because we have recently signed an MOU with the NITK regarding this project. So hopefully we can send a few proposals soon. Okay, thank you, sir.
Yeah.
Thank you.
Yeah, and then one of the, as a reply from one of the student groups, Mohammed Aslam, they say that they already have a space club in the college called Astral Space Club. So I think they can be in contact with NIT through one of the faculty members and get things done.
Yeah.
And maybe, as Professor Manoj had pointed out, maybe in future the college can also be part of launching a satellite.
Yeah, this I told you sometime back. No, Veer Surendra University.
So I think
Veer Surendra University in Burla, they are launching rockets from their Orissa launch site. We have given them launch site from Balasore to launch. They are making rockets, and their students are launching rockets and small satellites from there itself. So there, they have come up with a proposal. We definitely, then when they come with the proposal, we are encouraged and we have funded them also.
Yeah. And Venkitakrishnan, I think we have covered almost all the questions. I'll send you the text of all these questions, and if you need to answer anything more, it can be done. And the full of this recording, this will be recorded and it will be kept in the archives. And anybody who wants to hear, they can hear that later and be in touch with Dr. Venkitakrishnan.
Yeah.
Now, one last question. It's from your classmate Nandakumar.
Yeah.
Will we be having one more chairman of ISRO from GECT?
How can I tell? Definitely, I may not be. But if your question is aimed at me, I am retiring in May, so I don't have any chance of becoming anything now. Okay, I cannot say that anymore. Will not be there because a lot of bright students are coming up from GECT, and if somebody is joining, and definitely I am saying that there can be. We have already 2. We have. I think Dr. Ad Ingenium as chairman, and Dattan as VSSC director. So we had 2 actually, and definitely any more can be there. It's a good college, no? We are all from that college. We are very proud of that.
Yeah. Thank you, Venkitakrishnan, and all the best.
Okay.
All the best.
Thank
now
you
I request the principal, Dr. Sheba.
Yeah.
Yeah, Dr. Sheba to just present the certificate, and I think Professor Ajay can show that certificate once again. Dr. Sheba. Dr. Sheba?
I think there is some problem, I think. It's okay, fine then.
Yeah, I think college,
Okay.
I present this certificate of appreciation to you, Venkitakrishnan. We are very thankful
Thank you so much.
for having been
Yeah, thank you so much.
with
Yeah.
here. And we feel that because of your passion towards the college and your passion towards the space applications, we'll definitely come back to you, sir.
Thank you so much, and have a nice
So
day.
on behalf of the Alumni Association and the college as a whole,
Yeah.
I present the gratitude and thanks for
Thanks a lot.
giving us
Thank
a
you.
wonderful presentation, Venkitakrishnan.
Thank you so much. Yeah. And wishing you all the very best. Okay. Thank you so much. It's okay. It's over now. Can I leave then? Thank you so much.
Yeah. So if you have got any other queries, you can.
Yeah.
Yes.
It's okay. Thank you so much. Thank you all. A wonderful day, and all the very best for their bright future. Thank you so much. Yeah.